Part 2, Greenhouse Effect. Before we move on, we need to talk about, it's a review of 3 different ways that energy moves. So the first one is convection. If you remember, a fluid could be a liquid or a gas. When it's exposed to heat, it expands, and as it expands, the volume increases, causing to become less dense. As it's less dense, it's able to flow up to the top. As it flows up to the top, it interacts with different objects and it begins to transfer its energy, right? So it begins to cool. As it cools, the volume decreases and it becomes denser again, so it comes down, right? So this is a convection. A radiation is energy that's transferred through light. Okay. And the last one is conduction. It's actually when 2 objects are touching each other. So this does not need to touch, this does not need to touch, but conduction is through touching. 2 objects, one hotter than the other, right? They have to be not in equilibrium. So when an object touch each other, the movement of one object is going to start to move the other object, and that's how heat is transferred. So conduction, convection, and radiation. So the greenhouse effect. If you take, and this is not in the slide here, so if you take a ball and you hit the ball against the wall, you're going to notice that when the ball comes back, it's going to come back at a different angle. And the reason for that is because when the ball touches the wall, it loses energy. And because the energy is lost, it's going to come back at a different angle. So imagine if there was a place like a chair or something, so the ball could not come back to you. Okay. So then the ball would be more close to the wall than close to you. So in this analogy, you are the sun, the wall is the earth, and the ball is heat. So the greenhouse effect is pretty much this. Solar energy is able to enter, but not all of it is able to come out. And the reason for that is because when it hits the earth, it loses energy, and then it gets trapped by greenhouse gases, which is this barrier over here. And the reason why it gets trapped is because it comes in very strong with short wavelengths. However, when it hits the surface of the earth, it goes from ultraviolet to infrared, which is weaker, and because it's weaker, it's not able to leave this surface. Okay, so solar energy we emitted has less energy and longer wavelength, what we call infrared radiation. I have another slide that goes through this in a really nice way, so let's go over this again. So let's talk about this one more time. So energy from the sun is in ultraviolet, visible, infrared region. I don't know why it's not going to, oh, I have to do this. Okay, 47% of it reaches the earth, and then as it hits the earth, it bounces back, it radiates back. It radiates now in an infrared region. Okay, and about 70% of the radiation returns to escape, and the other actually gets absorbed by those greenhouse gases. So a small part of the atmosphere is made up of heat-trapping gases, greenhouse gases. These gases absorb long-wave radiation. They're called greenhouse gases, and some examples are water vapor and carbon dioxide. This is the final model. So we have been working on this model since part 1. So now we can look at the energy input. Okay, so this is the energy input from the sun. The energy output, some of it gets reflected back, has the albedo, right? So some of it gets reflected back and goes out of space, and some of it gets actually trapped by gases, those greenhouse gases. Okay, so this is how the Earth's energy budget is modeled. only a little over half of the absorbed energy is re-radiated. What happens to the other energy? Well, the energy that leaves, that is able to escape the greenhouse gases, actually gets radiated into outer space. The energy that stays actually is responsible for Earth's temperature. Okay, so that's what heats up the Earth. Part 3, we're going to go into more details what makes those gases so special.